Let us start mathematics polynomial. Let us start mathematics, and I am going to start algebra. Why algebra? It is the most important unit in the CBSE board examination, and I am going to start polynomial, which is the second chapter in your NCERT book. First of all, students, what is polynomial? An algebraic expression. Listen carefully. An algebraic expression in the form, which form? An x की power n, an minus 1, x की power n minus 1, an minus 2, x की power n minus 2, and dot 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 a1 x plus a0. This is the general form, but it is an algebraic expression. The most important thing in this equation, n is going to decrease. If n is going to decrease, then this will be the highest power, because n minus 1, n minus 2, and it is going to decrease. It means n is the highest power. So if this is the highest power, then it called degree, and degree define the types of polynomial. What are the types of polynomial? Suppose that first I am taking the example 2x plus 3. In this equation, the x power is 1, means the highest power is 1. The highest power is called degree, and degree is equal to 1. It means it is called linear polynomial. Clear? Second, I am taking the example x square plus x plus 1. The highest power is 2, means degree is 2. That is called quadratic polynomial. And third is, I am taking the example x cube plus x square plus x plus 1. The highest power is 3. It means degree is 3. Then it is called cubic polynomial. So in the basic concept of algebra, what is polynomial? It is important. Algebra expression. So the main concept here, that degree is 1, it's called the linear polynomial, degree is 2 is called the quadratic polynomial, degree is 3 is called the cubic polynomial. And what is degree? Is the highest power in the given polynomial. Okay, this is the basic concept. Let's come to the next topic. So now students, we have discussed all the concept. Now I am going to solve exercise 2.1. Here you have seen the equation y equal to px, and we have to find number of zeros in the graph section. So before going to solve the exercise, I want to discuss one important point regarding y equal to px. What does it mean that y equal to px? Okay, so this is a very simple meaning, that y equal to px means that the linear polynomial, quadratic polynomial, or cubic polynomial, any equation that must be in the variable x form. And when we find out the number of zeros in this graph section, we have to see only the x-axis. Okay, so this is a very easy exercise. We have to see that how many cuts in the x-axis, okay, by the given line. In the question number first, we have seen that the straight line which does not cut in the x-axis means there is no cut in the x-axis. It means it has zero solution. Okay, it has no roots, I mean it has no zeros. In the second question, we have seen that there is only one cut here, only one, so there will be 1 0. In the third section, you see there's a one cut, there's a second, third and fourth. So there will be 4 zeros in the third graph. So here no 0, here 1 or here 4. So hope you understand well that how to find out the number 0 in the graph section. There is this line does not cut in the x-axis, so there is no 0. Here cut only the 1 point, so there 1 0. Here is the 4 cuts, so there is the 4 zeros. So now come to the next topic. Next topic is division algorithm for polynomial, and it is very common to all that dividend equal to divisor multiplied by quotient plus remainder. So let's start by taking an example, or so I'm taking about the question. Divide 2x square plus 3x plus 1 by x plus 2. Okay, so I'm writing in this form 2x square plus 3x plus 1, and this is x plus 2. It is very clear that this is divisor and this is dividend. Okay, but how to start division? Listen carefully. In the division, the degree of this quadratic polynomial is 2, and here the degree is 1. So you have to be clear how to find out the first term of the quotient. So divide the first term or the highest degree term 2x square by the first term of the divisor x. So it is cancelled. So what is the remaining? 2x. So you have to write the 2x. This is the first term of the quotient. Multiply 2x by x, 2x square. There must be same, and 2x multiplied by 2 plus 4x. Okay, change the sign. It is cancelled and it is minus x plus 1. Okay, now we compare this equation and this equation. Here the degree is 1, here the degree is 1, so there is no need to buy, only the minus sign, it is minus 1. You can see that the minus x upon x, so cancel, it is minus 1. So minus 1 multiplied by the equation, minus 1 multiplied this minus x, and minus 1 multiplied this minus 2, change the sign, plus and plus, multiply, 1 plus 2, 3. Now this is the constant term, and the degree of the remainder is less than the divisor. Okay, the degree of remainder is less than the divisor. So now the division is not possible. So this is the final division, and the quotient is 2x plus 1 and the remainder is 3. Okay, come to the next. So now the next exercise 2.2. So we are solving the first question, sixth part, 3x square minus x minus 4. What we have to find out? First question, find out zeros. We have to find out the zeros of this equation. Second, we have to verify relationship between zeros and coefficient. We have already discussed this concept, so I am going to solve this question. 3x square minus x minus 4. So we have to split the middle term. How to split the middle term? We have to multiply the constant term multiplied by the coefficient of x square. 4 3s are 12. We have to factorize 12 so that the difference of factors must be 1. Okay, the coefficient of x is 1, so we have to take care about that. The difference of factor must be 1. 4 3s are 12. 4 minus 3, so 4 3s are 12. 4 3s are 12, and 4 minus 3 equal to 1. So the difference of factor is 1 and multiply is 12. Okay, so this is a very simple concept. So write down 3x square minus, we have to 4 minus 3, x minus 4. Okay, 3x square minus 4x minus 3x minus 4, 3x square minus 4x, open the bracket, the plus 3x minus 4, x is a common, 3x minus 4 plus 1 is a common, 3x minus 4, 3x minus 4 as a common, and x plus 1 will be remain. So the value of this equation, this polynomial will be 0 when 3x minus 4 equal to 0, x equal to 4 upon 3. X plus 1 equal to 0, x equal to minus 1. So we have solved the first question, find out zeros. These two are the zeros. But how to verify? You remember about the sum of zeros. Sum of zeros. Sum of zeros means this one. Sum of zeros is 4 upon 3 plus minus 1. And what is the formula of sum of zeros? Minus b upon a. Okay? We have to solve 4 minus 3. 4 minus 3 equal to minus b. What is it b? Minus 1. And a is 3. Here is 1 upon 3 and minus minus plus. So it is verified. Okay? Product multiplied by the zeros, 4 upon 3 multiplied by minus 1 equal to c upon a minus 4 upon 3. What is the value of c? Minus 4. And what is the value of a? 3. So this is also verified. So hopefully you understand that find out zeros using the factorization by splitting the middle term, and this is the relationship between zero and coefficients. We have to verify, and sum of zeros will be equal to the sum of zeros minus b upon a and the product of zeros c upon a. Okay, let's come to the next question. So next question of exercise 2.2, we have to find out the quadratic polynomial, and they have given sum of zeros 1 upon 4 and product of zeros minus 1, and we have to find out the quadratic polynomial. So we know that let the quadratic polynomial ax square plus bx plus c, okay, and sum of zero is minus b upon a equal to 1 upon 4, okay, and product of zeros c upon a equal to minus 1. First of all, we will make the same denominator. Here the denominator is 4 and multiplied by 4 here and multiplied by 4 here, okay. So c upon a will be minus 4 upon 4. In both the sections we see that the denominator is 4. So the value of a will be 4 when we compare, and the value of b will be minus 1 and value of c will be minus 4. Okay. So we compare the values of a, b, c and we get the values of a, b, c. Now what we assume? Ax square plus bx plus c. So put these values in this equation. What is the value of a? 4. 4x square. What is the value of b? Minus 1. Minus x. And what is the value of c? Minus 4. So this will be the required polynomial when the sum of zeros and the product of zeros are given. Or second method I have discussed in the previous lecture. So required polynomial you can use directly x square minus sum of zeros x plus product of zeros. You can use it directly and find the answer. Okay, now come to the next question. So now in the division algorithm we are taking one more question. So let's see, the first term, the highest degree of the dividend is x cube. X cube terms is a cubic and this is the quadratic. So how to find out the first term, the quotient? Divide x cube upon x square. So cancel by x, so we write the x in the quotient, and x multiplied by x square, that will be x cube, that must be same, and x multiplied minus 2, it is minus 2x. Listen carefully, x multiplied minus 2, it will be minus 2x. That is written below the like term. This is very important concept. Change the sign. x cube cancel, minus 3x square as it is, and 5x plus 2x plus 7x. Okay, minus 3. Now, this is the divisor has the highest degree is 2, and here also 2. So just minus 3x square upon x square, x square cancels, so minus 3 will be the next term. Minus 3 multiplied by x square, minus 3x square, minus 3 multiplied by minus 2 plus 6. So write down the like terms, plus minus, this is the cancel, it is 7x and minus 9. Now you can see the degree of remainder is less than the degree of divisor. That's why division is complete. It is not possible. So the remainder will be 7x minus 9 and the quotient will be x minus 3. Now come to the next topic. So next question is exercise 2.3, question number first. Dividend is x to the power 4 minus 3x square plus 4x plus 5. And the divisor is x to the power 4 plus 1 minus x. So for the first term of quotient, we have to divide the highest degree of the dividend upon highest degree of the divisor. X to the power 4 upon x to the power 2. It will be cancelled by x square. So write down the x square here. Now multiply x square to all the terms of the divisor. X square multiplied by x square, it will be x to the power 4. X square multiplied by 1, it will be x square, but it is written below the like term. So x square multiplied by 1, it will be x square plus x square, and x square multiplied by minus x, it will be minus x cube. There is no x cube here, but write down x cube. Okay, change the sign, minus minus plus, cancel x square power 4. Here minus 3x square and minus x square will be add, and it will be added. So minus 4x square and plus x cube plus 4x plus 5. Okay. Now it can be written as the higher degree must be written first, but there is no problem. So the highest degree of this equation will be x cube. Okay, and in the divisor x square, so it must be cancelled by x. So write down plus x. X multiplied by x square will be x cube, written below the like term. X multiplied by 1, it will be x, and x multiplied by minus x, it will be minus x square. Change the sign, plus minus minus. It will be cancelled. Minus 4x square plus x square minus 3x square plus 4x minus x plus 3x and plus 5 as it is. Now the highest degree term minus 3x square, and this will be x square, it will cancel to minus 3. Write down minus 3 here, minus 3 multiplied all the terms in the divisor, minus 3 multiplied by x square, minus 3x square, and minus 3 multiplied by 1, it will be minus 3, and minus 3 multiplied by minus x, it will be plus 3x. Change the sign, plus minus plus, cancel, it will be cancelled, and this will be 8. So now there will be a constant term. Division is not possible because the degree of remainder is less than the degree of divisor. So this will be the final solution. Division not possible. So remainder is 8. Remainder is 8, and this will be the quotient. Okay. Hope you understand well. Come to the next question. So exercise 2.3, question number 2. I'm reading here. Check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. Hopefully you know very well that how to divide, because the basic concept is that how to divide. When you know that how to divide, it is very easy. All the question, the type is different in this exercise, but basically you have to divide. So if the remainder is 0, suppose that if we have to check the if we have to check the factor of the given polynomial, then we have to divide and check. If remainder is 0, then it will be a factor. Simple. So question number 2, first part, I am checking the factor t square minus 3 and 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. So they are asking about the first polynomial. This is the first polynomial and this is the second polynomial. So they are asking whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first. Okay, so dividing second polynomial by the first. So they are asking about, check whether this is a factor of this polynomial or not. So don't waste the time, just divide. This t square is 2t to the power 4 upon t square. It will be cancelled by t square, the 2t square, 2t square. This term multiplied by all the terms by the divisor, multiplied by t square, it is 2t to the power 4. It is multiplying minus 6t square, minus 6t square. Okay, you know very well why I am written here, because it's the like terms. So minus 6t square, minus, and it will be plus, it will be cancelled, 3t cube and minus plus 4t square minus 9t minus 12. 3t square upon t, 3t cube upon t square will be cancelled by t. So 3t plus 3t, multiplied all the terms. 3t multiplied by t square, it will be 3t cube. 3t multiplied by minus 3 minus 9t, it is written here. Minus plus, it will be cancelled. 4t square and it will be cancelled. 4t square minus 12. 4t square upon t square, it will be 5 plus 4. 4 multiplied by t square, 4t square, and it will be 12. Change the sign, minus plus, cancel. So you can see the remainder is 0. Remainder is 0. The remainder is 0 proves that t square minus 3, which is the first polynomial, t square minus 3, which is the first polynomial. It's the first and this is the second. The question is that the first polynomial is the factor of second polynomial. You have to check t square minus 3. The remainder is 0. Then remainder is 0. It proves that t square minus 3 is a factor of this polynomial. Means first polynomial is factor of second polynomial. It is very easy, but the whole concept is division. So okay, practice that. If you have any problem, you can send message on the group. And I suggest all the students who are weak in mathematics, you have to practice very well. This is a board exam, and practice much more. Come to the next question. So next topic is relationship between zeros and coefficient of polynomial. So let's see. If alpha, beta are the zeros of quadratic equation. Quadratic equation, ax square plus bx plus c. Alpha, beta are the zeros. Zeros means roots. If alpha, beta are the zeros of the quadratic equation, then sum of roots or zeros, alpha plus beta, what will minus k be upon a? Product of zeros, alpha into beta, equal to c upon a. This is the basic formula you have to apply. Take an example. Suppose x square plus 5x plus 10. This is an quadratic equation, and I'm talking about the sum of roots, alpha plus beta, minus b upon a, alpha into beta equal to c upon a. You have to apply, but how to compare? Listen, a is the coefficient of x square. Here you can write 1. B is the coefficient of x. Here is this is called b, this is called a, and this is called c. So first of all, you have to compare with the quadratic equation. Okay, minus b upon a, minus as usual, b, the value of b is 5 and a is 1, c is 10 and a is 1. So this is called minus 5 and this is called 10. So this is the relationship between zeros and the coefficient of the polynomial. The sum of root zeros, alpha plus beta equal to minus b upon a, and the product of zeros equal to c upon a. Okay, let's come to the next topic. So next topic is how to verify relationship between zeros and coefficient. So for this I am taking the question of your exercise x square minus 2x minus 8. This is a quadratic polynomial. First of all, we factorize this equation, split the middle term, x square minus 4 minus 2x minus 8. Okay, 4 to the 8 and the difference is 2. X square minus 4x minus 2x minus 8, x square minus 4x, open the bracket, plus 2x minus 8, x as a common, x minus 4 plus 2 as a common, x minus 4, x minus 4 is a common, and x plus 2 is the remaining. So this is the quadratic polynomial, and the value of this quadratic polynomial will be 0 when these two brackets compare to 0. X minus 4 equal to 0, then x equal to 4, x plus 2 equal to 0, then x equal to minus 2. So these are two zeros of this quadratic polynomial which satisfy. Now, so I am going to verify the relationship between zeros and coefficient when we talk about the sum of zeros. So these are the zeros, so we have to sum 4 plus minus 2. But what is the formula of sum of zeros? Minus b upon a. What is b and what is a? B is the coefficient of x and a is the coefficient of x square. So write down minus b. B is minus 2. A is 1. And 4 minus 2, 2. So 2 equal to 2. This is verified sum of zero. Product of zeros, 4 multiplied minus 2. And what is the formula? C upon a. 4 multiplied minus 2 minus 8. And C is a constant term which is minus 8. Upon A is the coefficient of x square which is 1. So minus 8 equal to minus 8. This is verified. It means that you have to factorize. After that, put the sum of zeros and the product of zeros. Okay. Now come to the next topic. The next topic is how to form quadratic polynomial when sum and product of zeros are given. So let's take one question. When the sum is given 4, sum what? Sum of zeros. And product of zeros is given 1. So let the quadratic polynomial be ax square plus bx plus c and alpha beta are zeros. So what we know about the sum of roots? Alpha plus beta equal to minus b upon a, and alpha into beta is a product c upon a. So in the given question, what is given? Sum of zeros 4 is a sum of zeros 4. So minus b upon a equal to 4 and c upon a equal to 1. So in this method, suppose if a equal to 1, then if you put a equal to 1 here, then the value, then b will be minus 4 and c will be 1. If we suppose that if a equal to 1, then after putting the value of a, we get the value of b is minus 4 and we get the value of c is 1. Then put all these values in the quadratic polynomial. So a equal to 1, x square, b equal to minus 4, x, c equal to 1 plus 1. So this will be the quadratic polynomial. This is one of the finest method, or you can use another method. I am writing the required polynomial x square minus sum of zeros x plus product of zeros. You can use the direct required equation. Sum of zeros given 4, x square minus sum of zeros given 4. So put the 4 and x as usual plus product of zeros is 1. So you can get the directly required polynomial using this statement. So these are the methods where you can form quadratic polynomial when the sum and product of zeros are given. So let's come to the next topic. Thank you for watching this video. If you have any doubt regarding the concept or regarding the questions, you can just mail at livevisionclasses2020@gmail.com, or you can also send message in our institute group.